CloudBees Flow is a powerful application release orchestration platform. It is the only solution with the versatility to start fast and adapt to unique customer needs. It has unprecedented visibility and control, is the most reliable at any speed and scale, and is the only unified platform spanning end-to-end application release orchestration. In this demonstration, I will be covering the various capabilities of CloudBees Flow, starting with application and environment modeling and deployment, then showing the self-service catalog for getting started quickly, release orchestration and pipelines, then DevOps Insight, dashboard and reports, and the DevOps Foresight machine learning predictive analytics solution, and finally role-based views, security, auditing, and onboarding. Let's get started. We'll start by looking at an application model in CloudBees Flow. The model-based approach in Flow separates the application from the environment. In this way, the same application can be deployed to multiple environments using the exact same model, the exact same process to ensure consistency and repeatability when deploying the same application across environments. Here is our application model. We can see that we have two tiers, the backend and frontend. Each of these tiers has components within them, the database and backend in the backend tier, and the Node.js frontend in the frontend tier. The component is defined with a reference to an artifact. In this case, the artifact is in the built-in artifact repository, but could easily use one of our many integrations, such as with Artifactory or Nexus, to point to artifacts that have been stored there. Each of the components also have processes associated with them that are defined to perform various actions like deploy and undeploy against a component. These component processes are combined to create the overall application deployment process. I'll open the deploy process. The process can model the complexity that is required for deploying various types of applications. Here we can see that we can branch and run steps in parallel with conditions on branches such as success, failure, or even adding custom conditions. Process steps can call a component process, stored procedures or commands directly, plug-in integrations, and even invoke manual intervention and automated rollback. Error handling is defined on each step. In this case, we will retry automatically 3 times. We can also continue or stop on error or invoke manual retry. The deployment process deploys both the backend and frontend in parallel and then converges on the service connectivity check. If the check fails, we will invoke automatic rollback, first requiring a manual confirmation. Rollback can be defined to go back to the previous state or to a predefined snapshot that is a known safe state. Rollback can be done at the full application level or be set at the component level to only roll back those components that failed during the deployment. You can also check whether or not the application needs to be undeployed before rolling back. Integrating native rollback in the deployment process minimizes downtime when there is an error in deployment. Snapshots on an application capture a version of that application, not only recording the versions of each of the components that are deployed, but also capturing the model of the process and application at that time. Using snapshots ensures that there is repeatability and consistency when deploying the same application across different environments. Snapshots can also be taken from an environment, capturing exactly what process and versions were used during deployment. Application dependencies can be defined on the application, showing which other application and versions must already be deployed in an environment before this application can be deployed. The application model defines what is being deployed and how it will be deployed. Now let's look at where this application can be deployed, the environment. The Acme motorcycle application has mappings to 6 environments. Let's look at the pre-prod Canary environment. We can see in the model that there are 2 tiers, mirroring the 2 tiers in our application model. The model visualization shows the mappings from application tiers to environment. Each tier in the environment has 100 resources that are static. During deployment, components in each tier are deployed across all of the resources. In this environment, we are using native rolling deployment capabilities to perform canary deployment. In the rolling deployment definition, we're using phases. There are 4 phases defined, deploying first 5, then 20, 25, and finally the remaining 50 resources in the tier. On deployment, users can optionally inject manual steps between each phase of the deployment. Flow has built-in resource discovery capabilities using plugin integrations like WebSphere and WebLogic to discover environments and create associated resources and models. Environment reservations are used to handle contentions or shared resources. Users can reserve environments for specific applications, pipelines, or releases, or even set up blackout dates for maintenance. Environments can be marked as requiring reservation, so nothing can be run against it unless a reservation exists. The release calendar view provides visibility across all scheduled release activities as well as environment reservations in one easy view for ease of planning and coordination across teams. The Acme Motorcycle application is also mapped to 2 environment templates, which are used to dynamically spin up environments at deployment time. Environment templates use resource templates to spin up the machine. Here is an AWS template. This template definition shows the cloud provider, AWS, and all of the details such as configuration, security groups, AMIs that are used during provisioning. And after provisioning, chef recipes are run on this resource for configuration. I also have a resource template using Azure as the cloud provider. Now if we look at the environment template, we can see that both the backend and frontend are pointing to the AWS resource templates. So both tiers will be provisioned dynamically at deployment time. The Azure environment template is a hybrid template. The front end uses the Azure resource template for spinning up a dynamic resource in Azure, whereas the backend is pointing to an on-prem static resource. Properties in CloudBees Flow are a very powerful concept. Properties store key value pairs and can be saved on any object in CloudBees Flow. The property browser shows all of the properties in this application. Properties can be used to store configuration details, variable counters, process outputs for reporting, and even for sharing data between processes in a pipeline or deployment. We are using properties on the environments to store environment-specific configuration details that are read in during the deployment process. Let's look at the dev environment. Environment inventory tracks application and component versions deployed to each environment with details down to the component versions and the version of the application model used for the deployment. This provides visibility and auditability into exactly what is deployed to an environment. Inventory comparison views are available to highlight discrepancies between 2 environments at a detailed level to quickly identify and manage environment drift. While I've been editing my application in the UI, I can click the DSL editor and view the entire application in our Groovy-based DSL. DSL is available for all objects in CloudBees Flow, so users can treat their automation as code. I can click Edit and make changes right here that will be applied to the application. Let's deploy the Acme Motorcycle application. I'll select my process and deploy to the dev environment. I'll deploy a snapshot. I can compare what is defined in my snapshot versus what is currently in the environment. I can see that only the backend component version will be updated in this deployment. I can set parameters to drive the process. With Smart Deploy enabled, only those components with new versions will be deployed. I can disable Smart Deploy if I want to do a full fresh deployment. I can decide whether to enforce dependencies and use the artifact staging feature to limit downtime by first staging the artifacts to the resources before running the entire deployment process. I'll click OK to run. I can view live progress of my application being deployed and go into the details to see even more. For auditability, I can click on any step and see the exact commands that were run. I can also look at log files and see the standard output for any step, for inspection or troubleshooting of issues. I can see that my connectivity check failed and rollback is being triggered. First, I will manually approve to confirm rollback. With that, my rollback process is started, and the application will be rolled back to the previous version. While users can model applications from scratch, we provide an easy launch point to get started quickly modeling DevOps automation in the self-service catalog. The self-service catalog helps accelerate DevOps adoption and promote DevOps best practices and consistent processes throughout the organization. Catalog items provide intuitive ways to start creating objects and automation in Flow with minimal user input. There are many built-in out-of-the-box catalogs with guidance to start automating common tasks and tools in just a few steps, and users can create their own catalogs with reusable templates for common DevOps processes and configurations. Let's look at the Applications catalog. Here you can see catalog items based on common app and database servers that can help users start modeling applications based on these technologies quickly using best practices provided by Flow. A user will just click Execute and enter parameters specific to their application and click OK to create a new application. These catalog items are using master components in Flow. Master components promote reusability of common practices across an organization by creating a common component definition that can be used either by copy or by reference, so users can copy and extend or refer to the common definition. The application's self-service catalog items are all using master components with best practice processes provided out of the box in Flow. Other catalogs include cloud provisioning to start a new environment using a common cloud provider. Containers create container-based applications and microservices, as well as discovery and onboarding of microservices. Users can also create their own catalogs and catalog items. I can create a new catalog and create a catalog items for capturing a snapshot. I can select the label that will be on my button, as well as the icon that will be displayed. For the definition, I can write my own DSL, call a plugin, or a procedure. I'll call the snapshot utility procedure. Custom catalogs can be used to expose and automate common tasks to users without requiring further knowledge of Flow. It's just an easy button click. Many of our customers use the self-service catalog for automated onboarding. Once they have established their common pipeline templates with practices to be used, new projects start with the catalog item to automate creation of the releases and applications. This is helpful for ease of getting started and ensuring defined practices are used across the organization. These templates are driven by DSL using parameters to determine the specific attributes of the release or application using a common release template. Here's an example catalog item for creating a release from template. I'll run it to create a new release for the Acme motorcycle application. I'll call it motorcycle release. And I'll select the blue-green release template to run blue-green deployments to production. Click OK to create the motorcycle release in CloudBees Flow. Here's the motorcycle release with all of the different views for the release across the top. In the release editor, you can see the entire release pipeline definition and planning details for the release. CloudBees Flow has detailed release planning and scheduling capabilities with start and end dates for the entire release. You can also set start and end dates on each stage. and plan down to the task level as well. This fine-grained control ensures that every single activity in the release process can be planned and milestones can be set to track progress. The release calendar view combines scheduled release plans with environment reservations to coordinate activities and identify conflicts. Here I can see my motorcycle release, as well as blackout windows and reservations on my environment. Tasks in the release pipeline can be set to run serially and also grouped to run in parallel. Here is a group where the deployment and SonarQube scan are run in parallel. It's easy to add a new task to a stage, and tasks can perform a variety of functions, calling native automation in Flow, such as deployment processes, procedures, utility functions, or manual steps, and can also call one of our many plugin integrations to orchestrate the entire toolchain in the release process. CloudBees Flow is the only ARO application with the concept of a deployer task, which abstracts the multi-application payload for a release from the actual pipeline definition. As you can see in each of the stages, which represent different environments for the release, there is a deployer task defined. I can then set the payload for which applications will be deployed in each deployer task. For this release, I only have one application in my payload, Acme Motorcycle. I could easily add more applications to this release as well. I'll keep this as a single application release. I also define which snapshot to use as well as which process to use to deploy it. Next, I define the environments and configurations for Acme Motorcycle across each of the different environments. For the dev stage, I'm going to deploy using the AWS Dynamic Environment template, spinning up the environment on demand. In QA, I'll use the Azure Motorcycle template. In pre-production, I'm deploying to the Canary deployment environment using the built-in rolling deployment capability to deploy the application in 4 phases across the environment of 100 resources. And in production, I'll be doing a blue-green deployment. Here, the name of the environment is set dynamically using parameters to determine whether to deploy to the blue or green environment. Let's walk through the release pipeline. Starting in the dev stage, we pull the JIRA tickets that are associated with the release and create a report that is attached to the release for traceability and data cataloging. Next, we do a git checkout and start our build in Jenkins. We wait for the build to complete and then trigger our deployment using the deployer to the AWS dynamic environment. At the same time, in this group of tasks, we run the SonarQube scan in parallel. Finally, we run unit tests after the deployment completes. The next task tears down the dynamic AWS environment. This task will only run if the unit tests passed. We use conditions to determine whether the unit tests passed with 95% or greater success, and will only run if the condition is met. We can also use wait conditions, which will make the task wait until a condition is met. In this way, if the unit tests don't pass, the devs have the opportunity to log into the environment and understand what happened. Finally, we update the JIRA tickets with new status. With that, the dev stage is complete, and we automatically progress to the QA stage because there are no gates defined between the stages. QA starts with the deployment to the dynamic Azure environment, runs functional tests, and then uses shift-left monitoring and our integration with Dynatrace to create a test run Web API tests, and then get the test results. These tests will monitor the API performance of the deployed application. The exit gate on the QA stage checks the Dynatrace test results and only continues on success. Gates in CloudBees Flow control the progress of the pipeline between the stages, with the ability to create an entry and exit gate on every stage. They are separate objects defined outside of the stage tasks. Separating the gate provides clear visibility into the governance and control on the pipeline. The QA gate is automated, using a custom condition to check the Dynatrace test results. If the condition is met, the pipeline will continue. Next, there is a manual gate for entry on the pre-prod stage that is assigned to the release manager's access control group. Only a member of this group has the authority to approve the gates. On this gate, we have also checked Use Approver's permission for further execution of the pipeline. This allows for separation of roles and tight access controls across environments, where dev teams have access to start the pipeline execution and in dev and QA stages. Pre-prod and production environments require more advanced permissions, so the pipeline continues execution with the approver's permission to the higher environments. Once we enter the pre-prod stage, we deploy to the pre-prod environment using Canary deployment. We run integration tests and then use the Slack plugin to send a real-time notification to a Slack group. The message informs the assigned user to come and verify QA and approve this manual task. Next, with our integration with ServiceNow, we create a change request in ServiceNow. There's another exit gate in pre-production that is automated based on the integration test results. And then an entry gate into production, which uses the bidirectional integration with ServiceNow and waits for approval on the ticket that was created in the pre-production environment. Once the ticket is approved in ServiceNow, it will automatically trigger this gate and start the production deployment. In our production stage, the first task is using the integration with MoogSoft to check for any incidents or issues in the production environment before starting the deployment. Our MoogSoft environment is down, so this step is disabled. Next, we run our blue-green deployment. The target environment, whether it is blue or green, is determined programmatically based on properties in flow. After the deployment, smoke tests are run against the environment, and a manual task verifies that we are ready to switch between the blue and green environment. At this point, we integrate with the Nginx load balancer to divert traffic to the new environment, and then update our properties so the next deployment will be to the appropriate environment. With that, our full production deployment is complete. The last stage in the pipeline generates post-deployment audit reports for gathering metrics and ensuring visibility and auditability of the entire release process. Now let's run the release. As with all objects, access controls determine who has execute permission on the pipeline. Only those users can trigger the pipeline. The release can be started in various ways. It can be run manually. It can also be scheduled to be run one time or on a repeating frequency. Webhooks and integrations with CI tools like Jenkins CloudBees Core can allow triggering a release at the end of the CI process. I will run this release manually. Before running the release, I have options to configure and drive how the release will run. First, I can select which stages of the pipeline I want to run, so I can disable certain stages if I want to just run dev QA, for example. I will go ahead and select all of the stages. There are also parameters that can drive the release process. I'll click Run to start the release. My release starts with the dev stage. The first task is pulling all of the JIRA tickets related to this release and creating a summary link. Next, we perform a git checkout and integrate with Jenkins to kick off the build and wait for it to complete. As these steps are running, summary links are created, linking to the evidence. With the Jenkins build complete, the next two steps run in parallel, deploying to dev and running SonarQube scans. With CloudBees Flow's progressive disclosure, I can click into the details of the SonarQube scan and look at the log files as the job is running, see the standard output that is being generated, as well as click on the step to see the exact commands that are run as part of this step. All of this data is available and tied to the pipeline for auditability. My deployment to dev is also running, spinning up my AWS environments. I can see that my instances are already being started. And if I go into AWS, I see the front-end instance has already been provisioned and is initializing. And now the back-end is also provisioned. While I'm waiting for the deployment to complete, I can review my SonarQube quality report that is linked in the evidence. The deploy to dev is complete, and now my unit tests are running. The unit tests completed, but my environment teardown failed. Again, I can click into the details to see what happened. I'll look at the log file and see that my environment name does not exist. It looks like I have a typo. I can go back to the release editor to fix the issue on the fly and then restart the release from where it left off. Let me fix the issue. I'm missing an R in motorcycle, and I'll click OK to save. Now back in my pipeline run, rather than restarting the entire release, I can restart the pipeline from anywhere. I could restart from the stage level, but I don't want to redeploy and rerun the tests. I just need to start from the task to tear down the environment. The change I made will be applied, so I'm able to adjust the automation while it's running. If I wanted, I could even change the order of tasks and more in the definition. I'll restart the task and add a comment for auditability. I can see clearly that this is the second run, and I can even view the comment. And for auditing purposes, I have full visibility into every run of this task. The teardown has been completed successfully, and my Jira ticket is also updated. Dev is complete. If I look at the summary links, I can see that all of the steps that were run through the dev stage created evidence that is all collected in one place. The pipeline run becomes the full documentation of the release, with links to all evidence gathered in one place. Jira reports, Jenkins builds, Git commit messages, SonarQube scan results are all available centrally. Here is the Jira report. My QA stage is now running with the deploy to QA started. If I go into the details, I can see that my Azure environment has started provisioning, and I can go into Azure to see the new instance being provisioned. In Azure, I see a new VM being created. If you remember, the Azure environment is hybrid with only one cloud resource and the other resources on-prem. Deploy to the QA environment is complete, and now my Dynatrace test run is starting. I'm using shift-left monitoring with Dynatrace to detect any performance degradations early in the pipeline rather than waiting for production. I've created the test run with the Dynatrace integration, run my web API tests, and then gathering the test results. If the performance tests pass, then only will my pipeline continue. The QA stage is complete. My performance tests passed. I can go into the summary to see the test report. Before going into pre-production, there is an entry gate requiring manual approval from the release managers. The release management group would have gotten an email notification to come and approve the gate. I will go ahead and approve. And my deployment to pre-production will start. Pre-production is a canary deployment with the first phase currently being deployed across the first 5 resources in the environment. I've set up the deployment to require manual approval in between each phase. The first phase is complete, so I'll approve to continue to the next. And I'll start the next phase. Phase 2 is also complete and deployed to the next 20 resources. I'll approve to start phase 3. The canary deployments are set up using native rolling deployment capabilities in CloudBees Flow. I can now approve and start Phase 4. Phase 4 deployed to the remaining 50 resources in my environment. And with that, the Canary deployment to pre-production is complete. The SIT tests ran, and now I'm getting a Slack notification. The notification is sent to a Slack room where anyone in the room who has access and authority on the approval can click verify and be taken right to the running pipeline to approve the manual step. The bidirectional integration with ServiceNow created a ServiceNow change request for deployment to production. My exit gate out of pre-prod was automatically approved, and in order to enter into production, the entry gate is waiting on the approval of the ServiceNow ticket. The link to the ticket is easily accessible in my summary. I'll mark the change request as approved, and the pipeline will automatically continue. The production stage has started with the MoogSoft check for outages skipped and blue-green deployment to production completed. After the smoke tests are run, I have a manual task to verify switching the load balancer to divert traffic to the production environment. I will approve this and switch the load balancer. If I go into the deployment details, I can see that I deployed to the production blue motorcycle environment. After the load balancer is switched, I'm updating the property that determines which environment will be deployed to, and I can see it's now been updated to green for the next deployment. With that, the production deployment completed, and post-deployment audit reports were also generated. The audit reports consolidates data across the release to create centralized reports for quick access. The approval audit report shows all of the approvals from the release. The evidence link summary report gives one centralized view into all of the evidence links that were created throughout the pipeline. The task duration report gives a summary of the duration of all tasks, and production audit shows the inventory across the production environment. With that, the release is complete. I can also look at previous runs of the pipeline from this same view, making it easy to go back and see previous releases, including all of the metadata that is stored on a release. The release path to production view provides a quick view into how the environments are looking as the release moves towards production, with green check marks indicating that the application with the correct versions has been deployed successfully to that environment. My release is looking good. I have the correct version deployed to each environment. Dev does not show because the environment was torn down. Here is a path to production view for a release with a large payload of applications and microservices that actually show discrepancies between what version is required and what version is deployed in certain environments. The release's planned versus actual view will allow me to track my overall progress relative to my plan. Across the top is the overall timeline of the release. And for each stage, I can compare the two bars, where the top bar is the planned timeline, the bottom bar is the actual time. I can see that while I started my release on time, I've slipped with each stage, pushing my delivery date out further. At the bottom, I can get even more insight into each stage with detailed start and end dates, highlighting if I was on or after plan. The elapsed time metric shows overall elapsed time for the stage, which is the duration since the stage was started, as well as breakdowns for my process time into automated and manual. Manual processes may be time spent waiting on manual tasks or approvals, or teams waiting for environments to be available. This wasted time can slow down the entire process, and the metrics let you quickly zero in on the inefficiencies. I can see that I have room to improve with the amount of manual time I have in my stages. If I want to look at the details, I can view the actual pipeline run outputs and evidence collected to determine how to improve. The Release Command Center provides deep top-down insight into the release. Built on the DevOps Insight reporting engine, the Command Center provides a centralized view of all of the activities and processes related to the release. Plugin integrations pull key metrics from the tools used across the end-to-end process, from work item tracking in tools like Jira, build automation from Jenkins, testing tools, and operations like ServiceNow. These metrics are combined with the flow release to provide full visibility across the entire process, creating one place to go to visualize the entire release with business and technical performance metrics. In the planning stage, you can see the stories that are associated with the release, build, test, and deployment success rates, and how many incidents have been created post-deployment. The dashboard has drill downs to quickly access the data behind the metric. I can also see the Jira stories associated with the release, and click directly to see the ServiceNow incidents. The Command Center provides that bird's eye view of the release, giving a clear picture how all of the phases of the release are performing. The motorcycle release takes a single application from dev to production. Let's look at the online banking batch release to see a more complex enterprise release. In many cases, enterprise releases are comprised of other sub-releases and groups of applications, each with their own pipelines and timelines and dependencies between them. In Flow, you can not only model the hierarchy of pipelines, but also the dependencies and enforcement of those dependencies. In this release, you can see that in the dev stage, we are starting 3 sub-releases, BillMinder, Spendy, and QuickBank. Each of these sub-releases in turn have their own 2 sub-releases, so there's a 3-level hierarchy. At the end of the pipeline in production, the stop releases task has a condition to wait for all triggered releases and pipelines. More complex dependencies can be added, waiting for any type of release or pipeline. With this level of nested releases, visualizing and following the dependencies can be challenging. With the release portfolio view, CloudBees Flow provides full visibility. I'll start running the release and open the release portfolio view. Here you can see the entire hierarchy of releases and live progress, status down to the stage level, and the ability to click in to view the details of each sub-release. The 3 dots means there is a dependency, and I can see that the Spendy release is waiting on the Spendy backend to continue. Spendy backend is waiting on a manual response. I can click into the release, approve the manual, and go back to the portfolio view to see that the release has almost completed, with all of the stages successful, indicated by the green squares. The portfolio view makes it easy to model multiple levels of nested hierarchies of releases and pipelines, and even define templates for reuse. You can automatically trigger dependency trees and enforce wait dependencies within the hierarchy. The portfolio view gives runtime visibility into the live progress of the entire hierarchy. Now let's look at how to model microservices in CloudBees Flow. Microservices can be modeled as part of an application or independently, with each microservice being an independently deployable object. We'll look at an application. The motorcycle hybrid application has both services as well as a traditional tier that may be typical of organizations that are in the process of migrating their applications to microservices. In this case, the backend and frontend are modeled as services, whereas the database is a traditional component. The services definitions have configurations that detail the number of service instances that will be deployed, as well as port mappings. Within the service is the container. The container definition references the image that will be deployed in the Docker registry, and additional details for deployment such as minimum CPU, memory, environment variables, and port mappings. CloudBees Flow is the only ARO solution that has native object models for microservices, containers, and clusters, unlike competition that merely call Kubernetes or Docker scripts without native modeling, making them susceptible to frequent API changes. This canonical model is independent of the specific container orchestration platform, so users don't actually need to know the API of the container platforms. This application is mapped to various environments, and can be ported between different container runtime platforms. Here I have this application mapped to Amazon Container Services, Google, as well as OpenShift. Let's look at the Google Container Engine environment. Here we can see we have the traditional backend tier for the database and a cluster in Kubernetes for the front end. The configuration details have the information for connecting to Kubernetes. The mapping from the motorcycle application to the cluster contains specific details for deployment to this container runtime platform. In this way, the same application or microservice can be mapped to different container runtime platforms, allowing for portability. At deployment time, CloudBees Flow automatically translate the configuration details into the appropriate native API calls for the target container platform using our integrations. This removes the difficulty involved in container deployment and microservices adoption. Let's try deploying the application to the Kubernetes cluster. Before I deploy, we can see in Kubernetes platform that there are no services running. I'll hit deploy, and now the clusters are being provisioned. Now I can see the services have been created. With the deployment complete, I'll go back to Kubernetes and see that both of my services have been deployed. I can check the endpoint and see that my motorcycle application has been deployed successfully. Our users may already have investment in containers and microservices and don't want to start modeling in CloudBees Flow from scratch. We have a number of ways for making onboarding easier. In the self-service catalog, if I go to the containers catalog, there are various catalog items for getting started quickly. Users can start by importing Kubernetes YAML files or Docker Compose files to automatically create the associated models in CloudBees Flow. They can also call Kubernetes or OpenShift Discovery to automatically create microservice models by interrogating existing clusters deployed to Kubernetes or OpenShift. Let's try importing a Kubernetes YAML file to automatically create the associated microservices. I'll paste in my YAML file and select the project where I want the microservices to be created. I can either create the microservices within an application or make them independently deployable. I'll make individual microservices. I'll click OK to run. The import successfully created 3 microservices. Let's take a look at them. Here is the front end, master, and slave. If I look, I can see that the entire container definition was imported from the YAML file, and the microservice is ready to deploy. Lift and shift in CloudBees Flow enables teams with traditional applications to start benefiting from container deployments without re-architecting their application. We start in the storefront microservice model. I have a single container defined in my service called storefront. This container definition is referencing the container image called storefront jetty in a public Docker repository. In the container definition, you can enter the details of the container configuration like CPU, memory, volume mounts, port mappings, and more. This microservice is mapped to one environment called storefront. The storefront environment model has a single cluster where the microservice will be deployed. This cluster is configured to deploy to Docker. With Electric Flow's model-based approach, the service definition is separated from the environment where it is deployed. I could easily take the exact same microservice and map it to another environment, deploying to the container runtime of my choice, such as Kubernetes, OpenShift, Amazon ECS. Electric Flow will automatically determine the correct actions for deployment. Now let's look at the deployment process for the service. Here we see that we have added a couple of steps before the actual container deployment. First, we are building and publishing a new WAR file. This could also be done in your CI process that would then trigger the deployment. Next, we do the actual lift and shift operation. Let's look at the details. We're calling the artifact to image Docker plugin procedure, which does the lift and shift, and providing as input the artifact location. In this case, our artifact is located in our local electric flow artifact repository. We could reference the artifact in your artifact repository, such as Artifactory. Now we provide the repository and image name that will be published and the template that the image will be based on. In this case, we are using the Jetty template. I can optionally add more configuration options for the container, such as ports, commands, and environment variables. The last step of the process deploys the service, mapping the service definition to my environment cluster and taking the correct actions to deploy it to Docker. Before we run the deployment, I'll go to my Docker Hub registry and see that I don't have any storefront repositories created yet. Now let's try running the deployment. I'll select my deploy process and deploy to my storefront environment and click OK. The deployment is now running the lift and shift operation, taking my WAR file and creating a new Docker container image and publishing it to my registry. Finally, the container is deployed to my cluster. With that, the deployment is complete. Let's take another look at my Docker registry. I now have a new repository created called Storefront Jetty. Lift and shift in a flow accelerates container adoption without requiring re-architecting your application or writing any code. Now let's look at the Smart Map Topology view, an interactive 3D visualization of microservices topologies. We'll start in the editor for an environment that has a single cluster configured to point to Kubernetes. This environment is mapped to an electric flow application with microservices defined. I could also access the Smart Map view from that application. All of my views for the environment are across the top, including the Smart Map Topology view. I'll click to open the visualization. I now see the 3D topology view of my Kubernetes cluster along with the flow environment and application it is mapped to. I can pause the rotation and inspect the details of the topology. In the center is my cluster. When I click on any object in the topology, detailed information is shown on the right pane. Each of the blue boxes represent the namespaces in the cluster. I can click to rotate and look at the default namespace. Each branch represents a service in this namespace. Here is a pod and the container running within it. As I click on each object, I see the live data being retrieved from Kubernetes in the right pane. With these details, I can quickly retrieve status and configuration for any object. At the container level, I can even access container logs directly for easy analysis and troubleshooting. As a developer, you have direct access to this view, so you can see your service and access its logs easily without any hassle. To complete the picture, I can see the connection to the electric flow environment containing this cluster, as well as the microservices and the application containing those microservices. This one-of-a-kind view provides full visibility into your entire topology. DevOps Insight Reporting and Dashboarding Framework is part of the unified CloudBees Flow platform, with a number of out-of-the-box dashboards showing key metrics across application release orchestration processes and simple GUI support for creating custom dashboards. DevOps Insight has an extensible model that can be extended to show metrics that matter to our users, pulling in data from their toolchain. This is the Application Deployments dashboard, one of the out-of-the-box dashboard. On all of these dashboards, we have filters across the top, such as the time frame, projects, applications and environments, and tags. With object tagging in Flow, any object can be given a tag for simplified searching and grouping of related objects. The Application Deployments dashboard has a number of widgets showing various metrics across deployments in Flow with breakdowns of outcomes over time, applications and environments with the most deployments, and more. Dashboard widgets can have drill down to view the data behind the metric. I can click on the widget and see the actual deployments and look into the details. Another out-of-the-box dashboard is releases, showing release trends for releases that are running through Flow. In this dashboard, users can focus in on the percentage of automation and longest running manual tasks to find the inefficiencies in their processes. Two dev-centric dashboards are the code commit and continuous integration dashboards. Code commit pulls data from SCM tools like GitHub to show metrics about code commitments, including frequency, repositories, and top commits by users. The continuous integration dashboard pulls in data from Jenkins to show success rates for builds, numbers of builds, and frequency, as well as the outcomes for the last 10 builds. The microservices deployments dashboard shows similar metrics to application deployments, but for microservices that are being deployed through Flow. The Dora metrics dashboards focuses in on the 4 key metrics identified by Dora that can impact process efficiency: change failure rates, lead time for changes, deployment frequency, and mean time to recovery. Users can also create their own custom dashboards. Here is a custom dashboard that pulls in various widgets to show release trends. I can go into a dashboard editor view to make changes to this dashboard. In this view, I can edit the actual dashboard, moving around widgets, as well as add a new widget. I'll give it a title and then select an existing report that is querying Elasticsearch. I'll pick the report Top Apps by Deployments and then select the visualization I want to use. I'll select the table visualization and then decide what my columns will be. I can even set custom drill down on the widget. Now when I view the dashboard, I can see my top applications widget. Users can even create their own custom reports to query the DevOps Insight data to build their dashboards. If I look at one of these reports, we have a GUI-based query builder that make it easy for users to create their queries without knowing the intricacies of Elasticsearch. DevOps Insight dashboards provide visibility across all application release orchestration processes and provide flexibility to users to create their own dashboards, reporting on the metrics that matter to them. Let's look at DevOps Foresight in CloudBees Flow. DevOps Foresight is the predictive analytics product for CloudBees Flow. Foresight comes with a pre-trained model and performs deep statistical analysis of data that is pulled from build, static code analysis, source code management, and CI tools to identify patterns and create risk scores for dev processes. In this view that we see the developer learning that is coming from SCM and CI processes. Using the pre-trained model, Foresight identifies the top developer attributes that can impact the outcome of builds. Here we can see how our developers score in regard with each of these attributes. We can go one step deeper and see the scores per developer. In this way, we can determine developer effectiveness and impact on release processes. Similar to developer learning, we also have code-based learning. Code-based learning takes data that is pulled from static code analysis and identifies patterns. Based on the model, we are looking at the top source code attributes that can impact build outcome and how our source code scores in these areas. We can go one step deeper and see the scores per source code file. Using this developer and code-based learning as well as CI data, Foresight creates risk predictions. These risk predictions take the influence scores from the developer, codebase, and CI and create an overall risk per build, where higher scores mean higher risk. These FICO-like scores combine the various influences on the build. We can go into the risk details to see the breakdown of the different attributes that are impacting the score. While DevOps Foresight comes with a pre-trained model, the model can be incrementally trained with user data. With DevOps Foresight in CloudBees Flow, users can focus on the development and build risk and understand their impact on release outcomes. CloudBees Flow is a single unified platform, providing all of the ARO capabilities presented in this demonstration. You can see all of the options available in the menu. For users in specific roles, Flow has persona-based views that tailor these menus and views for each persona. We have a number of out-of-the-box personas, as well as the ability to custom create personas. I can look at the definition of the Release Manager persona and see that the custom homepage is set for anyone who is in this persona, as well as a tailored menu which focuses on Release Manager roles. Product Owner is a custom persona, so I can decide what the product owner will see. Groups and users can be assigned to the persona. I'll log back in as Ray, who is a release manager, and my homepage is set to the releases view, and my menu is tailored to the items that are important to me. Role-based access controls in Flow further focus users by only displaying items they have read access to. The fine-grained access controls can be set on every object, such as an environment. I can view the access control list and see who has access on this environment, with settings on read, modify, execute, and change permissions. The access controls have a hierarchical inheritance model for ease of setting up policies across the server. Users can have even more personalized views with the My Work and Favorites pages. The My Work page lists all of the outstanding tasks that are assigned to the user logged in a central place to see everything that you need to. For quick navigation to the items that are important to you, any page can be marked as a favorite and quickly accessed through the Favorites dropdown. For auditability and traceability, every change that is made in the system is stored in centralized change tracking. I can view the change history for my object and quickly identify who introduced that error in the pipeline. There's even an option to revert to a previous good version of the object. We have seen the power of the numerous plugins in Cloud through the integrations that were called from the release. By visiting the plugin catalog, users can see the available plugins, manage and upgrade plugins, and go into the details. A plugin could even be extended with users creating their own procedures within a plugin. The UI plugin wizard allows you to quickly create your own new plugin based on automation you've defined in the system. CloudBees Flow has even introduced a plugin development kit for ease of authoring custom plugins. The development approach for CloudBees Flow has always been API first. Any action that is done through the UI is also available through APIs. Here is the documentation for the full REST API for CloudBees Flow. Users can easily write custom scripts and integrations with Flow using APIs. And they can use this documentation to first try out any of the APIs. We also have API bindings to Perl, Groovy, and Python. As you have seen, CloudBees Flow's DSL is very powerful. All objects in Flow can be represented in the Groovy-based DSL. Users can see DSL for all objects directly in the UI and make changes directly there, or export Groovy files and store them in SCM. The DSL IDE plugin allows for quick execution and building of DSL. New users coming into Flow can take advantage of step-by-step tutorials that walk them through introductory use cases. The tutorials guide users, showing them exactly where to click and what to enter. The Community Edition of CloudBees Flow has even more tutorials, with a full list of use cases that use seeded objects that are built into the Community Edition for a simple user onboarding experience. The Community Edition also has embedded introductory videos showing features and use cases for onboarding. CloudBees University is a great asset for new users coming into Flow. There are numerous courses and learning paths guiding users through beginner, advanced, and even administration-focused coursework that users can take at their own pace and earn badges along the way. The courses also have interactive labs that are completed on hosted environments. This concludes the demonstration of the CloudBees Flow application release orchestration platform. Thank you.